returned. Where were you yesterday?
He wasn't here, is he?
Yes, he wasn't here all yesterday. Okay. It's nice to know that people noticed you were here yesterday, huh?
You're not the only one.
Really? Okay. Oh, good. So as we were saying last time, iron is the element that requires the most energy to separate its protons from each other. So it's like iron is the most stable element. It's least likely to decay. In fact, it can't really decay, it's so stable. Iron is like the opposite of uranium. Uranium decays quite easily, it's quite unstable. Iron is the opposite.
Why is iron so undecayable?
Ask Jesus. It just is.
No, like...
Why is fruit sweet or...
No, like... If it's...
lemon sour. They just are.
If it's because of an attraction force, then I think other elements would have stronger attractions between their particles. Unless there's a reason iron has that thingy.
I don't know what's so special about iron.
Do scientists know?
Why is iron so stable? I was feeling you'd be unsatisfied with the... Yeah, as I thought. They said, here's a formula that determines how strong it is. And you can see iron will have the biggest value. I see. Yeah, okay.
Okay, what does this formula consist of? Like, what does it take?
It takes A and Z as the values. A being the atomic number and Z being the mass number.
So is it a ratio like between them?
No, it's a kind of a quadratic formula, but it has roots in it and cubes as well, cube roots. So it's a polynomial. But no, that formula is just describing the relationship that's observed, I feel. It's not a formula that, like Newton's formula, that's actually describing some physical process. No, I don't think it's particularly well understood. Okay, where were we? Oh, too far. Oh, sweet, that was the last slide.
Highest binding energy per nucleon.
Yes, correct, iron. Okay, let's have a look at these. I think we'll take turns. So you could do one, and I'll do one, and then you can do two, and I'll do two. So the first one, oh, by the way, all the masses are down the bottom here if you need them. Faisal, come on, try these questions. It's not going to be on the exam. Why is iron so stable? And if it is, I'll give you marks for writing down my answer. Okay? Huh? And if you wish, you can replace...
Jesus is the answer.
You can replace that with anything you'd like. I'm not fussy, it doesn't have to be that. You want to say Superman is the answer? That's fine too.
I was about to die today morning.
Yes.
Right in front of Lee.
Right in front of Lee?
And he was just sitting there looking at it.
It's good to know he has your back.
and I got on the bus for free today. Good day. No, I missed my bus, so I got on another one. It takes another takes another route, then I have to get on another bus. And then I'm on the other bus, and then I see my bus there. So we overtook him. It's like, yes, go, go, go. Then I stopped the bus, then I got on the one I'm supposed to be on. I didn't have enough money on the card. So I'm like, oh no, oh. And then I took my wallet out. I know I didn't have coins. I don't have coins. Can I use my credit card?
Can I use my credit card?
Seriously, I took it out, I kept it there. It's like, this doesn't, I was like, try. It doesn't work. Just get it. Okay, thank you.
You put your credit card on the ticket
Yes,
machine.
no, see. Thing is, so many people said, no, seriously, so many people said that the credit card actually works the contactless.
Really?
It's kind of, and it's like, okay, if it's a contactless, maybe.
But actually, you know what I think about now? It makes sense. Like, contactless should work. Like, really, it really should work. But I just think, bus driver, can I use my credit card? I've got American Express or Visa. Which do you take? This morning is the first morning I got a seat on the Lewis. So we both won this morning. Because I take the Lewis from the train station. And usually there's no seats. Usually you're lucky to get on it. So I stepped on and saw an empty seat. I'm like, what is this? Oh. Exactly, yeah. This never happens. So I don't know. It doesn't seem like a very busy morning for traffic this morning. Yahya is late because of his sleep, I'm sure. His alarm is probably still going off. Although Andrew's not here as well. And who else is it on?
That's it. Oh, wait. No, we're missing. 1, 2, 3, 4, 5, 6. Oh, nice.
Just those two? Okay, let's do the first one. Do you have it finished, Fuan? The first one's done? Good, okay. So, firstly, what we have to do is we have to calculate how much mass is missing. So which side will have more mass, the left or the right?
The left.
The left. So we have two hydrogen, two H2s.
Whoa!
Oh, bit of a lag there. 2 times 2.01410 minus our helium and our neutron. And the neutron is 1.00867. Now, what is constant for you, please, on the calculator?
I did not get to this answer.
Well, no! Wait, Americans still get it back. Okay. Yeah. Then times C squared. This. Yeah. Let's put it in electron volts for fun. And how many? We make it mega.
Oh.
3.26 mega electron volts.
Can you move the calculator?
Did you get that, Fuan? Ah, no, that's okay. I didn't ask for it. It's like I said, I just did it for fun. Sam will say what they want. If they don't, it's up to you. That's what Wong asked me last time. That's what I told Wong the last time. I have a question. Why do you ask me questions you have the answer to? You're not certain.
What does E equal?
I don't know. I've used the 23 constant on the calculator.
No. The E, you multiply this by C and then?
What do you say?
What?
E, the energy.
Oh, what is it? In electron volts, it was
No.
3.26 mega electron volts.
Concentrate.
Yes.
E equals
mc squared.
c squared.
Yes.
Okay, that's all.
Okay, try number 2 now, please.
Pair.
I'm getting a different answer for the first question.
Juan, did you get the same answer as me?
I got the same answer.
If they ask what the value of B,
What?
L,
2, 3.
What's the value of energy?
and
Yeah. Well, try number 2. See if you can get that one right.
Those AMU values, are they average or all the atoms have the same exact mass?
No, that should be the exact mass because that's hydrogen 2, not weighted average like you do in chemistry.
So they are all identical, they all have the same exact mass. All the
Yeah, because
atoms.
they should be identical.
For 2D, what do you mean by how many reactions?
2D, yes. So, basically, you have the formula, the nuclear equation at the start of question 2. And that is, when you calculate the energy, that's how much energy you get when one uranium atom has one neutron fired onto it. So my question is basically, if you had a gram of uranium, how many of these reactions can take place? So it's basically saying, how many uranium atoms do you have? Because each atom allows you to do this.
How many atoms in 1 gram?
Yes.
Okay. So we find the moles and then we multiply it by Avogadro.
So,
6.02 times 10 to the 23.
it's just 55. Just that 55 is the nuclear amount.
We find the moles and then multiply by. If the marking scheme says something like 5,900, but we write 6 kilo, do we lose a mark for that rounding,
5,900,
or 5,800?
and the answer says 6.
No, we write 6 kilo, but the
Oh,
marking scheme
6 is too much of a round. If it was like 5,951, then yeah. What's nucleon? Proton and neutron. Proton plus neutron. One what? One mole? Ah, no.
How many moles?
For uranium,
Produced by using 1 gram.
1 mole is 235 grams.
So
Yeah, I don't.
using 1 gram of uranium 235.
I better do this one.
I don't understand.
How many times are the particles calculated with the individual atoms? How many particles are there? Yeah.
Let's do this one. So let's have a look now on the left. So we start off with uranium 235. 235.044. Then add on a neutron, 1.00867, minus barium, krypton, and 3 neutrons. Barium, krypton, oh no, 1 krypton, and then 3 neutrons. This is the M. What did you say the constant number U was? 17? 17. This is the mass. 3.04 times 10.
C squared.
Oh yeah, no, I know, don't worry, I know that, yeah. I'm just writing down the mass because I might need it for later.
But the question didn't.
Okay, but then I won't write it down. Fine. Fine, I'll just multiply by C squared.
Oh, so you didn't see it.
Okay. 2.74 times 10 to the minus 11. Oh, I'm having bad luck today, Yusuf.
E equals mc squared.
Yes.
Okay, well, I'm not getting this.
Did you get the Farhan, did you get this answer?
Yeah, my answer is way off.
What answer did you get?
M is the mass difference.
Yeah.
And
Did you
then
convert it
C,
into kilograms?
It's massive.
how do I do that?
Like how I did it twice now, multiplied by U.
Okay. M has to be in kg. But I can find the answer and then, because it's all multiplying. Okay.
Oh, you're so kind. Throw. Awesome.
What's the constant?
For the third time, constant 17 on the calculator.
Thank you.
Now, can we do the next part? How many uranium atoms are in a gram of uranium?
It's a chemistry, right?
With chemistry, yeah. 235 grams of uranium is how much? 1 mole of uranium. So 1 gram of uranium is 1 over 235 of a mole. So Avogadro divided by 235 is the answer.
Multiply.
Avogadro divided by...
What?
Number of moles equals mass.
Oh, I'm sorry, they were just looking for moles here.
Yeah.
How many... Oh, sorry, I was looking at C. B, how many moles? Yeah, so the answer for B is 1 over 235. Okay, you got that?
Yeah.
And then for C, we multiply by Avogadro, you got that?
Yes, not divide.
No, I'm not divine.
Yeah, you said divide. You scared me. 2.566.
No, C, isn't it just 235?
No.
C.
Nuclei, atoms.
Atoms?
Apple?
No.
Nuclei is the plural of,
Nucleus.
yes,
So
a nucleus of uranium is,
It's protons and neutrons.
yeah.
So you have 2p5 protons and neutrons.
I don't know if this is a grammar thing. When I say nuclei, I mean plural of nucleus. And one nucleus is one complete center of a uranium atom, the protons and the neutrons. I'm not asking you for the mass number or the nucleon number. So, if it helps you, pretend I asked for how many atoms of uranium there are in 1 gram. But I need to give you synonyms for the exam.
nice. How many EAP assignments did you do?
No, 6 times 10 to the power 22.
6.02 for one. Yeah. Did you get an answer now? Did you get an answer?
2.5 for C.
Yeah.
Yeah, 2.5. 2.566 times 10 power 21.
Yeah. Good. Okay. I can't because it's not working. We'll say it again. Juan, say the answer for C again, please.
2.6 times 10,000 pounds.
Got that for Juan?
10 power.
21. D. What's the answer for D? Yep.
Yeah.
Same as C. Because one atom can make one reaction. Because if you look at your formula, how many uranium atoms do you need? Just one. And this one can produce then one of these, 3 of these. You just need one of them. So the answer for D is the same as C. What's wrong? The answer for D is the same as C.
Is this a past paper question? 'Cause
Uh,
it's nice.
It's based off of one, yeah.
Because it's nice.
Is this? Yeah. How many uranium atoms do you need for this reaction?
How many reactions?
No, answer my question. How many uranium atoms do you need for this reaction?
2 part atoms.
One.
To make
One.
BAKR and 3 Ns, how many uraniums do you need?
One.
Yeah.
Yeah.
So this is one reaction.
One atom, one reaction. I don't know if that's okay. How much energy can be produced by using 1 gram? So how do you get the answer for E?
Multiplied by...
D and A.
Multiply D by A. Exactly. Yeah, so could you do that multiplication, please? You got an answer?
Don't have the value for A, I don't know.
Oh, okay. There's the value for A. Juan? Sorry, what was the value for D?
2.566 times 10 to the power 21.
Reactions. So, Yusuf, you're just multiplying these together.
Is it negative 11?
Yeah.
7.03 times 10 to the power 10.
So 1 gram of uranium can make this much energy. Finally, for this part, a small town requires 10 megawatts of energy. How long could 1 gram power the city for?
Wait.
So power equals work over time. So time equals work over power.
Mega is times 8.
6.
6.
The power is
Yeah.
10 mega.
Yeah.
And the energy, the work you have, the uranium can do is this.
$70,030.84.
Okay.
7,031.
It's about 2 hours, isn't it?
7,031 seconds.
Yeah, it's about 2,000. It's less than 2 hours.
To 1.953.
Yeah. So 1 gram of uranium can power the city for 2 hours.
A 10
A
megawatt.
10 megawatt town, not city.
10 megawatt.
Yep.
1 gram of uranium.
Impressive, I think. You wouldn't power a city on 1 gram of coal.
Yes. Is diamond flammable? It's made
No.
out of only carbon.
Yeah, but
I read this.
you
No, I read
know
this.
carbon has
No, but
many
I read
different
this.
forms.
I read that diamond is flammable. I'm like, what?
Well, look, let me put it this way. Everything's flammable if it's hot enough.
Whoa, okay.
Alright? It's not like you can put the diamond, throw it into the sun and say, yeah, burn this. Right. Last one here, we'll do it together. So what is the mass defect of copper 63? So how could we get that?
What is the mass defect?
Excellent question. If only you were in the Wait. You were in the last class. I remember
That's
because
not
after the class I had to take my usual headache medicine.
No. Cousin is very awake in the class.
That too. And you were, because I had to take my headache medicine after the class. So how do we get the mass defect? Anybody except Faisal?
63 minus 16,
Yeah, if you look at copper, it's made up of, well actually, I think you might have to look up how many protons in copper might be useful. So let me just tell you right now.
63 minus 29.
Wait, are you telling me the number of protons? Yeah, 29. Okay, what else? So, copper has 29 protons, 63 is the total, and number of neutrons?
34.
So the mass should be the mass of 29 protons plus 34 neutrons. Should be. Let's calculate that.
That's the mass thingy. Deflect.
It's nearly that. So,
The difference between the given and that.
29, one sec. Yes. 29 times, now do we have the mass of a proton? Oh, it's on the calculator, of course. It's number 1. Plus 34, and what's neutron? Is it number 2? I'd say so.
2.
Now, wait, we won't write it like that. No, actually, I will leave it like that. That's what the mass should be.
In kgs?
In kgs. Now let's take away what the mass is. So if I look here, the mass of copper is 62.91367. So minus 62.91367 U's. This should be 0, but it's not. It's this. Meaning that's how much mass is missing.
But it's
This is called the mass defect. Yeah. This mass defect was used as energy to bind it together. Let's calculate how much energy it is. What formula is that? E equals mc squared. So if I multiply this by c squared, that's the binding energy. Finally, what is the binding energy per nucleon? How many nucleons are there in copper 63?
divide this by 63.
Yeah, 63. So final answer is this, but it's more usual to put this in electron volts, so we might as well do that. And mega, I say as well. So for copper, it's 8.76 mega electron volts per nucleon binded. this is the energy required. So this means if you wanted to separate your copper, that's how much energy you would need per binding nucleon. Okay, we'll go to the next lesson now, yeah? Yeah, oh my goodness, people keep asking me this. Yes, if the question doesn't say, then you can. Right, so write something down. Did you write what I just did?
I was looking at it because I didn't know what it was, so now I write mass
Yusuf, you got this? It's okay?
equals masses of
Can I close this?
nuclei.
I can close this? Well, I can close this. Yeah?